In today's video, we'll see how to convert a bipolar signal into unipolar and vice versa. Bipolar signals oscillate between positive and negative values, while unipolar signals oscillate between positive values only. We can start by having a look at the phasor, which by default produces a unipolar signal. And to visualize its waveform, we can use a tab write, which is a node that writes data inside an array. Here we need to specify the name of the array we want to use. Let's say we want to call it array 1. But of course we need to create one. So let's create it. Make sure that the name is the same you wrote inside the tab write. And we can create it. From here, tab write needs to be updated with a very fast pace. So let's say every 100 milliseconds we want to update it. And of course we want to turn on and off the metro using a toggle. And here we have our unipolar signal. To convert it to bipolar, we can use the exp tilde, which is a node used to write mathematical expressions. So in parentheses, what we want to do is to catch the incoming value and multiply it by 2. So we want to double its amplitude. In pure data, if you want to refer to a variable, you need to write the $sign. And depending on its type, whether it is a float, integer, or an audio signal, you want to use F, I, or V. Since we are dealing with audio signals, we'll be using the V. And 1 is the index of the variable, since we could have multiple variables coming inside the same node. From here, we can multiply it by 2. And now we can have a look at what is happening. As you can see from here, of course, the amplitude it's twice the previous, but we are not centered to the 0 position. To do so, we need to apply an offset of -1. And here we have our bipolar signal with center position at 0. Now let's do the inverse. So we can start from a bipolar signal like the one produced by OSC. We can visualize it using tab write inside a different array. So array 2. We create the array. And we can use the same metro to trigger the tab write. And here we have our bipolar sine wave. If we want to convert it to unipolar, we use expression once again. Let me bring it down. Okay. And in parentheses, we catch the incoming audio variable. And this time we divide it by 2. Since in programming languages multiplication is more efficient than the division module, we'll multiply the signal by 0.5. And now we can have a look at what's happening. So we can disconnect the first link between OSC and tab write. And here we have our signal with half amplitude. As we did before for the phasor, we need to offset the signal and we can apply a plus 0.5. And here we have our unipolar sine wave. Hopefully this video was helpful for you. If so, I invite you to give a like and subscribe to support this series. As always, thank you for watching and I'll catch you in the next one.